Let's test audio testing. 1, 2, 3. Okay. All right. Again, morning to those online. I just wanted to quickly ask: did you guys have any questions about the exam or anything you wanted me to discuss, or should we just hop on to the next chapter? Okay, so let's move on to chapter 8 and discuss forecasting. So forecasting is an interesting topic. It's something that almost all businesses use because the future is uncertain, and we want to try and gain a measure of confidence about what might happen in the next couple of months or different time periods into the future. So this chapter looks at business forecasting. What are the different things we need to know about forecasting, and how could we go about calculating a forecast, and also how can we go about determining how accurate our forecast is. Okay, so for this week, we're going to look at what are the different methods and how do we apply those methods in Excel, and how do we analyze the error associated with our forecasts. Okay. So chances are that we covered this topic with you, or with you covered it with some other professor in 3 or 5 when you look at management science. But we re-emphasize it here because forecasting is a tool that is pretty vital. Okay, the basic rules of forecasting: forecasts are always going to be wrong. Okay, if you have a forecast that's consistently accurate, 100% accurate, then chances are that you don't really need to run a forecast, because that activity is something that's certain. Okay, so we only run forecasts in situations where we really don't know what the future holds for us, and we're trying to reduce the risk associated with an unknown future. Okay. Short-term forecasts are usually preferred to long-term forecasts. So if you're planning to rely on a forecast, it makes more sense to rely on a 3-month forecast than a 1-year forecast. And this is evidenced if you imagine last year in January, if somebody put together a 1-year forecast of what 2020 would have looked like, chances are that that forecast would have been so off, it would have really not even, you'd have to go back to the drawing board. Okay, that would be different from, say, a 2-month January, February, or January, February, March forecast, which wouldn't have been impacted as much by what happened with COVID and all that. Okay. The other rule we have is that when you're forecasting, it makes more sense to aggregate your forecast rather than forecasting for individual units of product. One way of looking at this is, if you look at a company the size of General Motors, and they try to project how many cars they're going to sell over the next 1 year, it might be easier to forecast that entire line of different cars that they have, for the Chevys and stuff, and say we're going to sell a total of say 150,000 vehicles over the next 1 year, than trying to break it down into the specific units and say that we expect to sell exactly 10,000 Chevy Camaros or something like that. Okay, so grouping an aggregated forecast is usually more accurate than a forecast that's broken down into individual units of product that the company sells. And the final law we have here is that forecasts are not a substitute to actually calculating information once it becomes available. Okay, so whenever you forecast, whenever you get additional new information, add that information into your forecast to have a much more accurate forecast. Okay, so there are multiple ways to go about doing a forecast. But one thing that we want to do is, first of all, understand the macro environment of the forecasting that we plan to do. Okay, if we know what historical information has looked like, we can get a pattern, or we can start determining what's the best approach given the pattern that we have. Okay, so if you have a pattern like this, where the amount demanded by customers over time does not really go up or go down. It's consistently similar amount of product over a period of time, then you'll be forecasting this with that in mind, that you're not really, customers are not really ordering much more, they're not ordering much less. So we should be having some stable form of demand. Okay, that's different from one where we notice a pattern where customers are purchasing more and more of our product over time. So if I have this type of historical information, I might want to factor in trend. Okay, there's a trend here, there's an upward trend. That means that the fact that we sold 90 units last month doesn't mean we're going to sell 90 units. It might mean that we're going to sell more than 90 units in the next time period. So we have a trend adjusted forecast that we would use if that's the nature of the demand that we have. Okay. We also consider seasonality, and seasonality just basically the effects of different time periods of the year which have specific demand patterns that will be witnessed based on the nature of the product that the company sells. Okay. If we are selling skis, chances are that our demand in the fall and winter will be much higher than in the spring or in the summer. Okay. If we're selling ice cream, it could be something similar, but we actually have adjustments that we would make if we have product that has seasonality to it. Okay, the certain product that might not exhibit seasonality, for example, milk. Everybody purchases milk year-round, so seasonality might not be a factor as much in the purchase of milk. But again, it depends on the nature of the product. You might experience some seasonality, and if you do, you want to make sure to capture that when you're forecasting. Okay. And the last pattern that we have here is a cyclical pattern. And this is long-term. This is 5-10 years. And the importance of capturing this is that when you're planning your forecast, it's good to know where are you in when it comes to the cycle of the macro environment. Okay. If I'm planning for an expansion in sales because I'm noticing a trend which shows that our sales are increasing, but I don't factor in to my equation where are we in the economic cycle of events, I might end up in a situation where I'm projecting more than I should actually project. Okay? And if you look at the US economy, these cyclical patterns that we have are usually pretty constant. Okay? And you'll find that the US economy operates such that every 8 to 12 years, we have this upward increase and then we have a recession. We have an increase in economic activity, 8 to 10 years later, we have a recession. And it's consistent, it's almost like clockwork. And so if you're ever planning to invest, that's something you might want to consider. Where are we when it comes to cyclical information? Okay. So I know that we had COVID brought some kind of a recessionary event, not as crazy as the last one, but that's 8 to 10 years after the last one, which was the Great Recession. And if you go back 8 to 10 years prior to that Great Recession, you'd have, what did we have? 2001, 2000, we had the dot-com bubble bust. If you go back another 8 to 10 years, you have, it takes us back to 1990. We had a recession around 1990, 91. So every 10 or so years, there'll be a pattern that you'll be experiencing in your data that you might want to take into consideration when trying to come up with your forecast. So these patterns usually involve making a kind of an adjustment to your forecast, tweaking it based on the fact that you understand that the recession, the economy is either moving upwards or trending downwards. Okay. So those are the four main patterns that you'll notice in data and you notice in the economy that will impact demand levels for any product that your company would be selling. Now, knowing that there'll be fluctuations in demand, the organization might want to figure out how we manage those fluctuations in demand. Okay, and some of those activities are usually split into two patterns of demand. You can either focus on marketing-based activities or focus on operations-based activities. Okay, so marketing, the guys in marketing can do certain things like promotional pricing if sales are low to boost sales, and that way they're kind of like influencing demand. They can offer complementary products if the specific product is not available, and that way the customers have an alternative option. When it comes to operations-based side activities, if you have a situation where you have a limited ability to make a certain amount of product, you could schedule those products, you could schedule the consumers coming into your facility such that you have a fixed number coming in at a given time. Okay. You could engage in backlogs where you inform your customers that we won't have product right now, but we might have it 2 weeks from now. Are you willing to wait 2 weeks? Okay. So these are different activities that the organization can do from a marketing or sales perspective versus the operations perspective, and it's all done to try and ensure that regardless of the spikes or fluctuations in demand, we can have product to the customer. Okay. So how do we actually go about forecasting itself? Forecasting depends on what is it that you're forecasting. Okay. If I am a company like Tesla, and I think you all remember this. You're coming up with the Cybertruck, right? Tesla's latest, still don't know when it will be actually on the road, but Tesla came up with this new electric truck with a futuristic design, which up to now I'm still conflicted. But there's no real pattern of demand that you can actually go back and say over the past 2 years, demands for electric pickup trucks have been so on and so forth. Okay, so in the absence of data or historical data, where we cannot actually make a decision, we must rely on more subjective approaches to forecasting. And those subjective approaches to forecasting are usually done in one of different ways, but they're usually judgment-based, based on experience, based on somebody else's expertise with the market. The organization will try and come up with a forecast that best mirrors the company's understanding of the market. Okay, so how do we do this forecasting methods? You can decide to rely on your sales department. Okay, and sales force estimates usually requires that the sales director or the sales vice president reach out to the people in the sales department, ask them for their opinion of what they expect sales for this product to be. Okay, in this case here, with the Cybertruck example, if Tesla had a sales department of say 40 different sales personnel, they'll send out feelers to all the different sales people, ask them if we were to start selling this today, what are projections of demand? What do you guys think? Okay, and the logic behind this is that those in sales understand the market. Nobody understands the market, hopefully, than the people in sales, and they will be able to give you a gauge of what the market can absorb. And those estimates are taken, averaged out, and you have a starting point where you can say, based on the sales force estimates, let's go ahead and make 10,000 units of product. The executive opinion approach does it slightly different and looks at what do company executives, the C-level executives, think would the forecast be for the product that we're trying to make. Okay, so it basically does something similar to the sales force estimate, but instead it focuses on what do our directors, what do our vice presidents, what do our CEOs and CFOs think we should start producing at that the market could absorb. Okay. Market research is also a pretty popular way of doing this. Have a market research company go out, ask questions to the market, and come back, use statistical methods to try and project what those responses meant. And the final method we have here is the Delphi Technique. The Delphi Technique is kind of like an all-inclusive technique where everybody, not everybody, but people within an organization from the different departments are surveyed and asked questions about what they expect that future forecast to be. Okay, so it's a multiple-stage process where you come up with your question. It could be, what do you think the forecast for this new product would be in 2021? Okay, and now this approach requires multiple departments. So they could have people from accounting, they have people from operations, they have people from marketing. Okay, so you ask each and every department, come up with an estimate of what your forecast would be. And accounting sees things slightly differently from marketing or operations. They could come up with a number of, say, 2,000. Operations guys might come up with a different number, say 3,500. Marketing might be very optimistic, come up with a number of 5,000. So after those initial digits have been put out there, you'd go to your second round of questions and ask them, why did you think our estimate should be 2,000? Why do you think it should be 3,500? And why did you come up with that figure? And that will give you a new set of information that these guys might have had, that these other people might not have had. So with that new information, the company will ask them again to give another estimate based on that new information. Okay? And with that new information, there might be that second round might see a shift in the amounts forecast. And this can go on for second or third round until we come to some form of a consensus of what future demand might be. Okay, so the Delphi technique is usually a back and forth multi-step process, which tries to get opinions and ask questions about why do you think this should be. Okay. Now notice too that all these methods here rely on the personnel's experience and understanding of the market. They're subjective, so they're not always going to be what they need to be, but it's better than having no forecast. Okay. For the purposes of our class, we're going to focus more on objective measures of forecasting. So it's good to know about these, but we need to actually deal with numbers and try and figure out how do we actually go about then calculating our forecast if we have information available to us. Okay. Now, what makes for a good forecast is also important. Okay. A good forecast is a forecast that gets us as close as possible to the actual demand once it's realized. So if we forecast that Tesla is going to sell 3,000 units, that's our forecast F over that time period. And when the demand is realized over that same time period, we find our demand equals 3,000, then we'll be like, whoa, that's really great. Our forecast actually matched our demand data. Okay. In this case here, I might ask, what's our error? What's the error between the forecast and the actual demand realized? And in this example here, we say our error was 0, meaning our forecast exactly matched our demand. Okay. And that would be great if that could be happening each and every time. But more often than not, that's not going to happen. So we need to figure out what's the magnitude of error that we have, what's the difference between what we forecasted and what we actually ended up selling, and is there a technique that can actually make that value smaller such that the error value here is as close to 0 as possible. Okay. So before we go into the different types of forecasts, let's review the different measures of forecast error and how to ensure we're coming close to that value of 0. Okay, so we have a bunch of different measures for calculating forecast error. When I worked in corporate, actually worked in a forecasting role, I would, you don't use all of them, I just focus on two. My biggest focus was on these two, but each and every one of these has a role to play in trying to understand the amount of difference between the forecast and the actual demand once it was realized. Okay. So we have the cumulative sum of forecast errors that basically just looks at how much error do we have for a given time period, what about for the next time period, and so on, and then you sum up those errors and it gives you a value. I'll look at an example of that. From that CFE, we can actually get an average by dividing that CFE by the total number of time periods we forecast. The mean squared error looks at the error amount, but it tries to show was there any value of error that was larger than it should be. So what I find to be most useful with MSE is that if you had some error, some forecast which was really off, then your mean square error would be pretty large and you tell you there's something very wrong. Okay? If your squared errors are close to zero, then the MSEs will be really small and it tell you that you're doing a good job at forecasting. Okay? The mean absolute deviation and the standard deviation just basically look at if you have to see on average what's the difference on average between the forecast and the demand, the mean absolute deviation would be perfect for that. And the final measure we have here, MAPE, basically just gives you a percentage of, okay, how big is this error compared to the actual demand realized. Okay? So the mean absolute percentage error is great for explaining because if I'm using the mean absolute deviation, and we have here a value of 2800, the mean absolute deviation, if it's just for that one period, would be the difference between this here, which would be 200 units. Okay, so I can say that my mean absolute deviation is, we're usually off by around 200 units, but that might not be as useful because you might be off by 200 units, but if you had sold 3 million units and then your forecast was 3 million, your demand was 29999,800. That 200 units might be not as significant as that 200 units here. Okay, so the mean absolute percentage error tells you that, you know what, this 200 units as a function of the demand. I could pull up a spreadsheet here. So let's say we have our forecast, and then we have our demand. And I mentioned that we could have a forecast of 2,000 units, but we end up selling 2,800 units. And in that case, our error here would be the difference between the forecast and the demand. We have an error of 200 units, okay? Because it's only one time period here, the mean absolute deviation here is going to be almost, will end up being 200. So let's compare that to the situation where you sold 3 million units. I mean, you forecasted 3 million. That's 3 million. Zeros. And you ended up 299. Okay. So in this case, we have the same exact unit difference in terms of our forecast and our demand, but the mean percentage error enables me to say that, you know what, this difference here was a difference of 200 divided by the actual demand. And I'll do the same for this and change it into percentage. Okay. So despite the fact that our error is the same 200, this error here is a pretty sizable error of difference between the forecast and the demand of 7%, but 200 out of almost 3 million, it's a really small percentage error. So the mean absolute percentage error enables me to have a value, a measure of the magnitude of the error relative to demand. Okay. So MAP is a great measure for trying to explain that, you know what, for the last 1 year, our average error has been approximately 7% of demand. So we need to maybe work towards bringing that value down. Okay. So let's look at some examples, and I'll ask you to go into Blackboard. Blackboard, in-class activities, forecasting workbook. Okay, so the typical question that you'll be faced with in this chapter will always have these two columns, your actual demand versus your forecast. Okay, so you're always going to be having that. One of the first questions that you'll be asked is what the forecast is going to be for the next time period. Okay, so in this case, I'm going to skip that question, but we're going to come back to this when you look at time series methods and stuff. But for right now, let's focus on the measures of forecast error. And let's look at the different error measures that we have here. Okay. Let's start with our CFE. So the cumulative forecast error just basically compares the difference between these two columns, the actual demand versus the forecast, and error is just the difference between these. So very basic, 39 minus 41. So in January, we had an error of 2 units, February 6 units, and so on and so forth. Okay. If I sum these up, these errors, if I sum those up, sum of these, that's 10 months worth of errors, I get this value of 31. Okay. And this value of 31 gives me an initial measure of bias. Okay, and bias in forecasting is you basically try to decide, do I usually forecast too much or do I usually forecast too little? Okay, if you have a negative value here, then it tells you that on the basis of the information you have here, for the most part, your forecast is usually higher than your actual demand is. Okay, so your forecast is biased towards the higher side. So from a perspective, because you want to bring that value closer to 0, you might try and ask yourself, how can I bring that value more in line with the actual demand data that we have here? Okay, so that's just an initial, CFE is an initial measure of bias. That basically tells you that, yes, you have a good forecast, but you tend to overestimate the amount that the customers are going to need. You can take that value of negative 31 and divide it by the number of months or time periods that we have here, which were 10. And that gives you your average bias. Okay? The average bias just basically says that for any given month or any given time period, your forecast is usually off by around 3 units, and it's usually higher than the actual demand. Okay? So I might want to find a way to bring this number closer to 0, because the closer it is to 0, the less bias there is in my data. So those are our first 2 measures. of forecast error. The larger that value is, the more biased your data is. So you want to make sure that that number is as close to 0 as possible. Okay. Now let's look at the next column. And the next column is the absolute error column. Now for the absolute error column, all I'm interested in is the size of the error, not the sign. Okay. So we already have the errors calculated in column D. And all I want now is the absolute value. So you can use the absolute value formula ABS and just get the absolute value for the error. ABS, or if you want, you can just type them in by hand, that's fine as well. Okay, so all I did is get rid of all the negative signs here and just get the positive values there. And it gives me the size of the different errors, regardless of whether we forecasted too much or too little. And here too, I can get the total. Okay, 81. But now I want to get the average of those absolute errors. Okay, so the average of those absolute errors would be 81 divided by the total number of months, which was 10. And I get an average absolute value of 8.1. Okay, now that absolute value of 8.1 is what we call our MAD, our mean absolute deviation. If you get a question, you can't remember what MAD was, just remember it is the means of the absolute deviations. Okay, so you first calculate the absolute deviations and get the averages, and that gives you that value, the mean of those absolute values. Okay, so this is a number I usually like because it tells me that if I look at the different numbers and compare, on average, I'm usually off by 8. I'm usually off by around 8 units. Okay. So again, I want that number to be as close to 0 as off because I want my forecast to closely mimic my actual demand. So the larger that value is, the worse my forecast is, and the smaller it is, the better the forecast. Okay. The next calculation we have here is the mean squared error. Okay. So we take the error values here and square them. So this squared raised to the second power. And I'll do the exact same thing down here. Just get the averages for each. Okay. And in this case here, my mean squared error value is 87.9. I mentioned before that the mean squared error magnifies the size of the errors, and if there was any value here that was excessively big, if our forecast was really bad in any one of these months, say I'd put here 10, then the MSC explodes. You start seeing it becomes large and says, hey, there's certain months there where you guys are really off. But if it's close to the actual demand, then you'll notice that the MSEs go down. Okay? So the smaller the MSE, the better. If it's really large, you know that there were certain time periods where you really messed up on your forecast, and you might want to go back and ask yourself, where did we go wrong, and how can we fix that going forward? The last column I have here is that percentage column where we'll try to look at how large is the error as a percent of actual demand. Okay, so here again, I'm going to go to, and this is, let me make a correction here. This is going to be the absolute percentage error. So let me use the absolute symbol. Absolute, did that work? Yep. Okay. So I'm basically referencing the absolute errors column here, and I'm dividing that by the actual demand information. So here we have an error of 2 divided by actual realized demand of 39. So we had an error of 5%. Our forecast was off by around 5%. for January, and I'll do the same for all those other months. And now I can see that there are certain months, like in July, I'm like, we were really off in July, okay? So we're off by almost 50%. We placed a forecast for 61, customers only ordered 41, so that was pretty large. January seems to have been the best. January and August seem to have done pretty well, okay? But as you can see, the percentage error gives you a measure that you can actually use to explain the size of that error. And then we do the exact same thing down here. We calculate the averages. And this average now enables me to determine that our forecast is usually off by approximately 17% of the actual demand. Okay. So from a business perspective, you'll have to go through the process of asking yourself, how can we have a better forecast? Should we use a different forecasting method? And what forecasting method should we use to make this better than what we have here? Okay. Another measure of forecast error is the standard error. I don't really care too much for this, but it exists. So you might want to know how to calculate this. So the standard error relies on the value of the total squared error, okay? And you divide this total amount of 879 by the number of time periods you have here minus 1. And then you square, and you get the square root. So in this case here, I want the square root, SQRT, of 879 divided by n minus 1. We had 10 months. 10 minus 1 is 9. And it'll give you a value of standard error of 9.88. So the standard error is usually pretty close to the mean absolute error value. Okay. And you just want to have that standard error value be as small as possible. Okay. So these are the basic, what we've done here is just basically look at the measures of forecast error. We have not yet done any forecasting, we've just looked at measures of forecast error given data, historical data. Let's look at one more example and then we move from that to actual forecasting. If you go to the second tab, the table shows the actual sales of upholstered chairs for furniture manufacturer and the forecast made for each of the last 8 months. Okay, so you calculate your CFE, your mean squared error, your standard error, your mean absolute deviation, and the mean absolute percentage error for this product. Okay, so again, the cumulative forecast error is just you basically summing up those errors. So it's a very simple addition, and you end up with a total, which I already have for you over there. And this here, I'll just put it here, CFE, your cumulative forecast error is the value I have up here. Color code this. Okay, or your bias, your total bias. Okay, and this tells me that's negative 15. Negative 15 tells me that my forecast is usually higher than the demand over the course of these 8 months. Okay, if I get the average of that of the errors here, then I get my mean bias, which in this case is negative 1.875. Okay, and that tells me that on average we're usually off by we're usually biased towards the forecast at an average of 1.875. The second question here is calculate let's do it in order. Let's do the absolute error. And let me have you guys work on this. Calculate the next column and come up with the average down there. That's the column of absolute errors. And this is where I get you to wake up if you're online, because I'm going to ask you to submit something to the Dropbox as part of your attendance grade. So please calculate the absolute errors in column E.
That's it, just
What's that?
just absolute error.
Yeah, just column E for now. And the average absolute error.
Wait, are you able to save yours?
No,
I'm not.
Yep.
It's not letting me save it.
Oh, it's not?
In the Dropbox.
You can't, can you save as?
I'm trying. Yeah, I'll try again. I said I didn't have permission to for some reason.
Oh, because I didn't put any protections on this. Let's see. No. Try and see if you can do a save as.
Yeah, I said you do not have permission to save files to this location.
Are you trying to save to your desktop?
Interesting. That might be it. Downloads and then to documents. And
What's that? No, you will. Before you submit, I'm going to walk through the rest of the questions. Okay. So, actually, let me make this easier. If you could please walk through the mean square error and the mean percentage, the mean absolute percentage error. Maybe change this a bit. I'm going to work my way through this. Okay, so it all should be done. So you can submit your responses to the in-class forecasting. Let me share my screen. Should be 3 responses. Into that in-class forecasting. So if you just click on that, you should have 3 simple questions asking you to submit the MAD, the MSE, and MATE. Yeah.
Doing the MATE to 3 or 2? It says 3, but then
Oh, sorry,
2.
that should be 2 decimal points. Okay. So that last question should be 2 decimal points for those online. Speed typing. All right, let me check to see if this is all done. Shouldn't take too long. Give it another 1 minute. See, slightly more than half the class has submitted responses, and they're all correct, which is good. This exercise shouldn't take you too long. I still have 6 people working on this. 2, 3, 4, 6. Please wrap up. This shouldn't be taking this long. Okay, and down to 2 people. 1 to 1. Seconds, Tucker. All right, please submit whatever you have. I'm going to close this Dropbox. So it's just should have been pretty straightforward. Okay. All right, so if you did it correctly, you'd have the responses I have here. Oh, makes sense to share the screen. Okay. The absolute error measure is just basically taking your error column, getting rid of the negative signs, and you come up with the values over here, and then get the average for that, and that gives you a mean absolute deviation, which tells me that on average, this forecast is off by around 24 units. And those 24 units means that your forecast is usually off by around 10%. Okay. So your forecast is, the bias here was negative. So it means that we forecast usually higher, and our forecast is usually higher by around 10% of the actual demand. Okay. So those are our measures of forecast error. Let's go back here. Now, having kept those in mind, why were we doing that in the first place? So we know we need to figure out how much of a difference we have between the forecast and the actual demand. But these measures of forecast error also enable us to figure out if we have multiple forecasting methods, which we're going to be looking at today on Thursday, which is the best. Okay, so we might have 4 different options. If I calculate the mean absolute deviations for 4 different forecasts, and I find that one specific forecast has a pretty low mean absolute deviation, then I'll say that that's the forecast we should use, and we stick with that. Okay. Now, if you ever find yourself in a forecasting role in corporate, a lot of this is done. We have software which you just say, let's use a 3-month moving average, or let's use an exponential smoothing method. And once you program it into your SAP or into your Oracle or whatever software, EDI software you'll be using, then it will continue calculating your forecast with that specific approach until you tweak it and say, let's use a different type of forecasting method. Okay. So now let's look at, let's introduce some of these forecasting methods. Okay. Now, one of the most basic approaches to forecasting is a causal approach to forecasting, where we say that X causes Y. Okay, so causal forecasting is useful, especially when you know that there might be a relationship between one activity and some independent activity. Okay, and for all causal forecasting, we use the equation of a line approach to try and draw a regression line that shows you that if we had a certain amount of X, then we should expect a certain amount of Y, right? So we all know the equation of a line formula. We also know that the equation of a line formula has multiple parts to it. It has the Y-intercept, okay, and that's going to be captured there. We also have the slope of the line, which is captured by the B in the formula here. Okay, so we have 2 things we're interested in here. What's the slope of the line, and what's the Y-intercept? Okay, and on the basis of these 2, we can make a forecast. Okay, let's look at an example here. So here we have a situation where we are looking at causality. One thing causes the other. We're not looking at time. This is not a time series. We're looking at what causes what. Okay. So in this case here, the manager believes that if we spend a certain amount of advertising dollars, we can expect sales to be at approximately a certain amount, right? So in this case here, if you're trying to ask yourself, what's your independent variable, what's your dependent variable? Sales depends on advertising. Okay, advertising does not depend on sales, so it's the other way around. And that's how you figure out what your Y and what your X. Okay, your Y is your dependent variable, so your dependent variable sales depends on your X, which is your independent variable, advertising dollars. Okay, so now we want to use this information here to try and project, and we could actually project if I spent a certain amount on advertising, then how much should we expect our sales to be? So I'll copy this table here into Excel. So I'm just going to add another month here, and I want to know what would happen if I spent $3,000 in advertising. How much would our sales end up being? Right? So we don't know what that sales value is going to be, but I do know how much I could potentially spend. So this is our focus of interest in should we spend more, and if we spend more, how much should we expect back? Okay, so I could initially start off by graphing this and trying to see the trend relationship here. But we have tools in Excel that can enable us to calculate this thing very quickly using the line equation of a line formula. Okay, so for me to do that, I'm going to go into my data tab, go to my data analysis option at the top up there, and I'm going to be looking at for my regression tool, regression. Now the regression tools asks you what's your X and what's your Y. So it's very important that you understand what's your dependent variable, what's your dependent variable. And as I mentioned, your Y is your dependent variable, okay? So in this case here, sales depends on how much you pay for advertising. So my range here is going to be this values here, and my X values are going to be advertising spend. I have labels here. I want my output right here on this chart. So let's put the output here. And that's all I need to be able to get a solution, a summary output. And with this summary output now, we can go ahead and try and figure out what's the answer to this question. If I spend $3,000 in advertising, what should we expect our sales to be? Okay. So going back to the equation of a line, y is equal to a plus bx. For me to be able to figure out what my y here is going to be, I need to know what's my a, what's my b, what's my x. Okay, so I already know that my x is already given as 3,000 or 3. I need to come into this summary output and find my a and b, and that's going to be found right here.
Dr. Chia, quick question. How did you get to the regression formula?
Oh, sure, let's do that again.
Yeah, I can't find the analysis.
Oh, okay, so that I should have mentioned. So if you don't have that, you can just add it. It's usually hidden until you activate it. So if you don't have, to get rid of this. If you go into your data tab,
Yeah.
and you don't see the data analysis up of the, it's usually going to be on the top right-hand corner. You don't see it?
No.
Okay. Somebody else has a question here. Okay. So go into File and Options, and under Options there will be Add-ins, and look for the Analysis Tool Pack. Okay. So once you click on the Analysis Tool Pack, don't click on OK. Click on Go at the bottom. And it will bring you the analysis tool pack there. I already have it checked. Make sure yours is checked and then click OK. And then it will bring you to the data tab. So analysis tool pack, you are not using Solver in this class, but I usually have those two checked. Okay, so once you do that, you should have the data analysis tab for those online, is anybody who didn't get that data analysis tool? Okay, so let's do it again. So to run the regression on this, as I mentioned, you need to know what's your Y. I'd even advise you, just so you don't get confused, make sure you put your Y somewhere there and mention what your X is. Because if you do it the other way, you get completely erroneous results. So make sure you have the right Y, the right X. And remember here that Y depends on X. And X is independent. Independent. Okay. All right, so let's go back into the data analysis tool, look for your regression, click OK. It'll ask you to input what's your Y range, and I input everything, including the label at the top. And if you include the label, make sure to check off the label, like a radio button or something. And I did that for the Y range as well as for the X range. And you also have to tell Excel where you want the summary outputs to be put. And I usually just say put it on the same spreadsheet. So I clicked on cell F1. You can click anywhere in your spreadsheet and just say OK. Okay. So when it gives you this output, I should have deleted all this. You have your intercept. This first thing you see here, the -813, that's your intercept value. Okay, that's your A in the formula. And then your slope is given as 109. Okay, so this is your Y-intercept. And this is your slope. So I'm interested in using these, and now I can use those two values, pop them into the table up there and calculate what our expected sales would be. So that means that Y would equal our Y-intercept plus our advertising spend multiplied by the slope multiplied by the amount we're spending on advertising. And so we come up with a solution. Mine is shown here as 319. Okay. So that tells me if we increase our advertising spend, we should expect to receive some corresponding amount of sales. Okay. And you can always visualize this on a graph. Insert. Okay. So this is what I have, but I'm using the wrong metric to. I shouldn't have used month with these two columns here that we're analyzing here. And I need to switch. So the data looks accurate, but I have a problem in that my Y information is down here, and I should have it on this on the Y-axis, and not on the X-axis. And a quick solution to that would have been for me to just flip these around. Cut, insert. Now I can go ahead and insert a diagram. And that shows me the nature of the relationship. And if you add a trend line here, it will show you that, yes, there seems to be an increase. When you add additional advertising dollars, we get additional sales. And if I add a trend line, then I see that upward trend. Increasing our advertising spend leads to increased sales. Okay. So this last value you see up here, that's our projected spend. Everything else is information we have. The only thing that we didn't have is this very last values, which was answering the question of how much sales are we going to get if we spend $3,000 on advertising. Okay. So that's the causal approach, where you say one thing causes another. You can use regression in such instances. We're also going to be using regression when we have time series type of data. The only difference is that unlike causal relationships, time series, your x-axis is just the time period that you have here. And you're just basically trying to see, is there an increase in demand over a certain period of time? Here the question was, is there an increase in demand the more we spend on advertising? Yes, Alice, I'll post the video. It's recording right now. Okay, let's, we have 4 more minutes left, so I won't go into yet another kind, but I just wanted you to whenever you see a question which asks you to go through causation, remember you're going to use the equation of a line. It's much easier to do it in Excel than trying to use a calculator. And the last thing, once you've done this, is to ask yourself, do you even understand what the Y-intercept is telling you here, and what the 109 that you have here is also informing you. So let me ask that question for the class. What's this Y-intercept telling us?
The Y-intercept tells us.
So we have a Y, let me reduce the decimal points here. Last thing we'll do, and then we'll go, just so you understand what you're looking at here. The Y-intercept, yeah.
Telling us how much, is it telling us that we're not spending enough on advertising?
No.
Okay.
So look at the visualization. This is the Y-intercept, this value right here.
Right.
Okay. So the Y-intercept is telling you if you spend $0 in advertising, how much sales are you going to get? Okay. So if you're not spending any money on advertising, you're actually not going to make a profit, you're actually going to make a loss. So this value is actually somewhere down here in this example. Okay. So without advertising, maybe due to costs and stuff like that, this company might end up making a loss. So that's the starting point for understanding what that formula up there has. So your Y-intercept is just basically what value are you going to have if there's no sales, there's nothing in your X column available. Okay. Now the slope here tells you that for every additional dollar that you spend on advertising, you get $100 worth of sales. Okay, so anytime you spend some money, I get back a certain, and in this case, because we had this in thousands of dollars, for every $1,000 spent, we make an additional $109 of sales. Okay, so that's basically how you'd go about interpreting that, and hopefully it makes sense that way. So if you start off at $0 spend $1,000 worth of advertising, it's going to move us from -8, which is at 0, plus 109. So we end up like $100 worth of sales revenue. Okay. If we add an additional 1,000, our sales will also increase by an additional 109, and so on and so forth. Okay. The last thing I'll talk about here in the last 10 seconds is these values up top here in your summary output, your multiple R, your R squared. These tell us the magnitude of the correlation between your X and your Y. Okay, so in this case here, also our correlation value is around 96%. That's pretty high, which tells me that there's a very strong relationship between advertising and the amount of sales we can expect. Okay, if this value was like say a 65%, then there'll be a moderately strong relationship. If it's closer to 0, then you can almost say there's no relationship between the two variables that we have here. Okay. All right, so I'm going to save this spreadsheet and we're going to continue looking at some more examples on Thursday. You have questions? Those online?
I don't have a question about what we went over in class, but the next concept application, is it due this Sunday or the 11th?
Yeah, so and now it's good you mentioned that because I have all your concept applications to submit. I'm going to work on those today and get them back. Let's go to our schedule. No. We do have them there. So this, I'm going to push this, okay? I'm going to push it out to April the 11th, okay? And I'm going to make that revision in the syllabus, and so it's going to be due at the same time as the inventory management assignment, not this week, okay? Thanks for bringing that up.
You can do what?
You said with the homework for.
The concept application assignment,
Okay.
yeah. The next one that's due, which is supposed to be due this week, okay? All right, so I'll see you all on Thursday. You'll take care.
Have a good one.
Yeah. Thank you.